Molecular solids are made up of individual units of covalently bonded molecules that are attracted to each other through weak intermolecular forces. So here is an example being dry ice, which is carbon dioxide in a solid phase. So the individual CO2 molecules have linear geometry. So the dipole moments cancel each other out due to symmetry. So therefore the interactions between these nonpolar molecules are London dispersion forces. Because oxygen has a higher electronegativity than carbon, so you get temporary fluctuating dipoles. And this type of solid sublimates at a very low temperature, where it goes from a solid directly to a gas phase. And as we know with ice, the individual molecules are polar, so therefore ice melts at a temperature of 0 degrees, because dipoles are stronger than London dispersion forces. And when this turns into a liquid, the intermolecular forces are created and destroyed, so therefore they're rearranged. And the density of ice is lower than the density of water. So in general, molecular solids have a low melting point due to the weak van der Waals forces between the molecules. They're poor conductors because the valence electrons are tightly held between the covalent bonds and the lone pairs around each molecule. And molecular solids are sometimes composed of very large molecules or polymers, which are composed of many repeating units called monomers, which are bonded by covalent links in a chain, as we'll see.